today we are moving on to lesson 5, angle pairs. Your essential question: what is the difference between a linear pair and supplementary angles? Two things that we'll be defining in a second. Your two learning targets, the two things that you need to know for your test. Number 1, learning target number 7, identify angle pairs, and learning target number 8, be able to calculate values and measures of supplementary and complementary angles. Okay, so what do some of these vocabulary things mean? Well, number 1, adjacent angles. Adjacent just means right next to. Angles that share a ray. Okay, so just a quick picture. These would be adjacent angles. They share that ray in the middle. Another type of angle pair that you'll see today is vertical angles. If we want to draw a picture of vertical angles, we'd say, all right, well, this right there and that right there. These are considered vertical angles. You have two lines that intersect, and when you do that, kind of the opposite angles there, those are going to be vertical angles. Complementary angles are angles that make 90 degrees. Okay? They can either be adjacent like this. These two make a 90-degree angle, and so those are considered complementary, but they don't have to. You could have just kind of two different angles like this. If these are both 45 degrees, even though they're not really close to each other, they're still considered complementary angles because put together they equal 90 degrees. Supplementary angles make 180 degrees, right? Just like complementary angles make 90 if they're together and they're not. Same with supplementary angles. I could have them just like this. So these are supplementary because they make 180 degrees, or you could simply have, here's two supplementary angles. They're both 90 degrees and they make 180, and so these two are also supplementary. Okay, the linear pair postulate. The linear pair postulate basically just says that if you have a line, or if you have two angles that are adjacent that make up 180 degrees, these are considered a linear pair. So this right here, they make up a straight line. This is the linear pair postulate. And specifically, it's a type of supplementary angles where you have adjacent angles. All right, so moving on to some examples. Again, not going to be too earth-shattering today. Number 1, use that diagram to determine how the angles are related. So we've got angle PAL, that'd be this one, and LAM, that's this one right here. How are those two related? Well, they do share a ray, and so these are adjacent. Okay. PAO and NAM. Those be these two right here, and these two right here. Well, we have two lines intersecting, and so these are vertical. Okay, let's see, then PAO and NAO. Well, again, these two are adjacent, but I think there would probably be a better way of explaining it. Since PAN is a straight line there, we could say that these are, this is a linear pair. If you said that they were supplementary, you wouldn't necessarily be wrong, but that wouldn't be the most specific way of describing them. We want to be as specific as possible, and linear pair is more specific than supplementary. Okay, a little bit of algebra here. These two angles form a linear pair, as you can see. Find the measures of both angles. Well, we've seen this before with the angle addition postulate, except when we did that before, we had to tell you what the angle was. This is basically saying the same thing, except without saying it, we should know that that whole thing there is 180 degrees. So we have 3x plus 19 plus 7x minus 9 is equal to 180. And now we can just go ahead and solve for x. So I've got 10x plus 10 equals 180. Subtract the 10 from both sides, you got 10x equals 170, and so x is equal to 17. At this point, we are going to have to plug this back in, find the measure of both of those angles. So we've got angle ABC. Well, that one's going to be 3 times 17 plus 19. And so we'll just, 3 times 17 is going to be 51 plus 19 is 70. So this one is 70 degrees. And now we need the other one. We're just going to use kind of our common sense and say, all right, angle CBD be 180 minus 70 or 110. Again, clearly not drawn to scale. All right, this one would be made much nicer if there was some sort of diagram to it, but there isn't. So we'll just have to kind of draw this out. It says LM bisects angle JLN. So first of all, I'm just going to draw JLN. I don't know exactly how big it is, but I don't know if it really matters right now. LM bisects this, so that means it cuts it in half. We're going to be working a lot more with bisecting things in the next lesson. If JLM equals 42, what is JLN? So we've got some adjacent angles here, and well, I do know that if it bisects, it cuts this in half, which means this is also 42, which means JLN would have to be, angle JLN is equal to 84 degrees. Alright, so that's it for angle pairs.